Hello everyone. Today I will explain you how to interface external memory and other peripherals to the 8051 microcontroller. Okay, here is a simple block diagram of interfacing external devices to the 89652 or 89651 microcontroller. Usually 89651 has 4 KB of internal flash and 89652 has 8 KB of internal flash. And if you take 8031, it will not have internal memory at all. So with this configuration you can use internal flash as well as the external memory, say this SRAM of 32 KB, both for data as well as the program. Okay, this 8255 is a peripheral port interface. That's if you want additional ports you can interface this chip, otherwise it's not of importance. So in today's class we will only concentrate on how to expand the memory of 89C51 or 52 for more program and data. So here what we can do is idea is to use both internal flash of 4K or 8K along with external memory for the code. So this is actually a schematic or a block diagram for the development board, where you can write program and download it into the RAM and execute from the RAM. Okay, so this feature is realized through some kind of a monitor program that resides in the internal flash memory. So upon reset, this monitor program will run and it will listen to the commands through serial port or UART port. So what you can do is you can implement a program that starts at the RAM location, say 8000, relocate the vector table to starting from 8000 address, and then download that program into just SRAM at 8000 address, and then jump to that 8000 address. So it starts running your application program. So it's a kind of a development program or a development board. Okay, so here if you see here 2 pins are used for I2C interface. So if you want some applications to be stored statically in your development board, you can use this I2C based ESCAPE-ROM. So upon boot you can give commands to the monitor program to load one of the application from this ESCAPE-ROM into the RAM and start running it. Okay. Then you have the bootloader and the reset switch. So bootloader is like it's an IO pin indicating whether to run the internal monitor program or stay in the boot mode or to run in a normal mode. Okay. So port 0 and port 2. So if you look into the pin diagram of 8051, so port 0 is used for lower multiplex address and data bus actually. Okay, so there is a 8-bit data multiplexed with the lower 8 bits of the address. So you have address latch enable signal as well. So what you have to do is you have to use a 8-bit latch and connect this port 0 pins through 8-bit latch. So whenever there is a address placed on this port 0, the ALE signal will be asserted. So when this signal is asserted, the address bits or the address values, lower address values, will be latched into this latch. Okay, so that will be A0 to A7, and during and port 2 will generate the upper addresses, upper 8 bits of addresses. Okay, A8 to A15 actually. So here we need only up to A14 because we are using only address space up to 32 KB, not the full 62 KB address space. Okay, and so we have this RD bar. Okay, this RxD and TXD are used for RS-232 communication with your terminal program. And this MAX232 is a TTL to RS-232 TTL converter and vice versa. Okay, Now we have this RD read bar and write bar signals, so that are directly connected to the peripheral port. But for SRAM, the RD is connected through an AND gate. Okay, AND gate, and there is also program store enable, which is also going as input to this AND gate. So the thing here is, so this 32 KB memory is not just used for data, it is also used for instructions or program instructions. Okay, so when you are fetching an instruction, both program store enable as well as the read signal will be asserted. Okay, so read signal will be asserted, and also you can see this EA is the right external address, so that is activated, it's also asserted. So it tells the controller that external memory has been interfaced. So the control signal generated by the microcontroller will depend according to this EA signal. So during normal read or data read or the code read, so both RD and PSEN will be generated, and that signal is used to generate the enable the RAM output. And if you see, for write, the write signal directly goes to the SRAM as well as to the port, and you have this A15 address line. So okay, so that is connected to the inverted and connected to the chip. So this occupies the upper address space, and A15 is directly connected to the chip select line of 8255. So the lower 32 KB address space is used for this port pin, memory mapped IO port. And what else? Okay, the data bus is connected to data bus of both external peripherals, that is RAM and 8255. Along with the A15 address line, the A0 and A1 is also used to address the external peripheral port. Okay, so A15, A0 and A1, they address this external peripheral port, and the addresses, the upper addresses, that is from 8000 and above. So A15 is inverted, so it is 8000 and above will be used to access the SRAM. So writing program for this development board can be achieved in two ways. One is using the assembler, 8051 assembler, or you can also use the Microvision Keel Microvision compiler. So there is an option where you can set the reset address and the reset interpreter table to 8000 and build your program. So that will generate the X file starting from 8000. So then you can download that X file into this board through RAM. Okay. Yeah. So if you want to see the machine cycles about accessing external memory, you can see there is an instruction called as a MOVX, that is for the accessing the external data. Without this MOVX instruction, you see that for every states, okay, every state's ALE is generated, asserted in state 1. Then you also see the program store enable asserted for in state 2, and RD bar or the read bar signal is asserted throughout 12 clock cycles. And every time the program store enable is asserted, you see the program counter upper byte being output on port 2. On port 0, you see the address being output, and when the ALE goes low, that is the lower program counter address is output. and when the ALE goes high, it is actually fetching the instruction opcode or instruction bytes. It's reading back the instruction bytes, instruction in. Okay, with the move instruction, the signal asserted on PS EN is different, and RD bar is also different. That is because during the cycle 2, first will be the instruction fetch, and then we'll use the DPH operand as part of the MOVX instruction, or the PC operand as part of the MOVX instruction. Okay, so the instruction being read into in the first cycle, and in the second cycle the data is being read out, okay, from the external memory. Okay, that's all for today's class. We'll come back again with another class to explain you about addressing modes and instruction sets of 8051. Following that, I will start with the programming. Yeah, thank you.